Hi, welcome to Data Structures and Algorithms class. My name is Uyewale Ademola, and I'll be your tutor for the class. All right, uh, I'm going to just briefly introduce myself. I am Ademola once again. I'm a software engineer. I currently work at HelloFresh in Berlin, Germany, uh, where I work as a senior backend engineer. And prior to that, I worked at Chatdesk as a software engineer and as a team lead, right? And that's a few of my work experience. Uh, so prior to that, how did I get into data structures and algorithms? While I was in school, I participated in programming competitions. I I always had interest in data structures and algorithms and how to apply them to solving real world problems. So I did a lot of this competitive programming, and it's been a very good journey so far. That being said, um, I still do a lot of algorithms these days, and I'll be walking you guys through what this course entails and how to get the best of what of this data structure and algorithm course. Right. So we have a brief topics to cover. So, what does a rundown look like? So, we have a set of topics, we have materials to give, we have homeworks, quizzes, and then we have graded submissions. And at the end of the day, we have like a full project where you can um, show off what you've learned so far, because that's in this course, it's learning by doing, right? So, uh, in every day, we do we apply this course, but we are probably not aware. For example, if you go through, if you have a phone number list book, how do you search, right? How do you look through to know, right? You probably mentally look through and say, oh, alphabetically, I'm going to start with A, and then if it's ordered alphabetically, you know if you're looking for a name such as Smith, right? You just go to where S is, and then subconsciously you know to look for SM, and then get the number you're looking for. Like take it as an example, a dictionary. If I'm looking for the word xylophone, right? I move till I get to alphabet X, and then before Y, and then I start looking for X, Y, L, O, right? That is a basic example of you applying algorithms in your everyday. And then something else we do is sorting, right? If you have a pile of books, sometimes you want to like arrange in a specific way. That is what like sorting looks like, right? So briefly, we're going to look at um, efficiency of uh, algorithms. What does it take to actually build a data structure? A data structure collects it's a collection of related data. So what does it mean when we say a collection, and what does it mean when we say related data? Right. So we have list-based collections. We have searching and sorting. We have maps. We have hashing. We have trees. We have graphs. And then we'll look at some case studies such as shortest path problems, knapsack, um, traveling salesman's problem, brute force, greedy solutions, dynamic programming solutions, and an expectation we have is that you are proficient in at least a language, it doesn't matter, be it Python, Java, Go, any language is fine, but you need to be at least be comfortable in a beginner level knowledge in the programming language. If that's not the case, I would advise you go back and then take a course on learning a new programming language. Right. So I'm going to walk you through an example. Why do you need to do this? Right? Why should I learn about data structures and algorithms in the first place? Right. So, for example, um, if I give you a number, four numbers, and I say I have one, two, three, four, and then I say I'm only interested in um, anytime I put in this one, two, three, four, I on the other hand, I need to it needs to be reversed, right? So that the if you give me one, two, three, four, when I get the result on the other hand, I see four, three, two, one. That means it's been reversed, right? So if it's been reversed, then what happened? How did this transformation take place, right? So we'll look at some interesting data structures. For example, right, what does it mean to say when we say a stack, right? What does it mean when we say a queue? right? If you go to the airport and then you see people lined up, right? It's the you get attended to in the order in which you are lined up, right? So that means whoever gets there first um, gets attended to first in the counter, assuming you there was no line jumping and it's everything is orderly, right? So that's an example of a queue, which means first in, first out, right? Which means uh, I got here first, and I should leave first, right? So, or you can say last in, last out. It means if you go there last, you'll be the last one to go out, right? And then we look at that's an example of a queue that's applicable in our everyday lives. Then we look at something else like what does it mean when we say stack, which means um, if you arrange your books right, and then say you sort your clothes in a box, right? Typically, if you are lazy like me at times, you only pick the clothes at the top, right? Even though, but because that is more handy. That is an example of what a stack means. So a stack means if you put arrange some items, no matter what it is, in a specific order, you whenever you need an item, you pick the first one. You just do like something like a pop, right? Which means take it off, right? Take the first item off. So if you are ordering, say, plates in the kitchen, right? You put five identical plates and then you wash one. What you are doing is when you wash the first one, you put it down. You wash the second, you put it down till you get to the fifth one. When you get to the fifth one, now you have five plates. But if you need to use the plates, if they are all clean, you take the first one, which was the last one you added, right? So that's an example of a stack. And then we'll be looking at what does it mean to say um, an array, right? A linked list, right? So, uh, what do these terms mean, right? And this you now start getting aware of because start becoming aware of your environment, how you apply these algorithms without you knowing every day, right? So we look at shortest path problems, we look at knapsack. Shortest path problems means how do I get from point A if I'm going from a substation to another substation or a tram to another tram? How do I know, okay, yeah, uh, what is the best way for me to get from one point to another while using the least amount of time, right? Covering the longest distance within the least amount of time. How do I make this efficient as possible, right? So that is what the shortest path problems. How can I, if I have to, like say, for example, a postman has to deliver three items to three different neighborhoods, right? And then the postman says, "Oh, okay, how do I deliver this using the least amount of time?" Right? So um, that is like a traveling salesman's problem where you want to touch all the points, but then you need to know which how to maximize the fuel. If you are given like a small amount of fuel to cover to deliver those three items, how do you maximize that so you don't run out of fuel before you complete the delivery, right? So and then we look at what it takes to say dynamic programming. When you say, oh, I need to use, if I've done something before, why do I need to do it every time? How can I um, reuse like a previous solution I've done? And then we look at like maps, we look at graphs, right? What does it mean to say this is a graph, right? Your Facebook connection, it's a connection, it's a graph entirely because you have a friend that's connected to another friend, but the friend knows somebody that you are not aware of. But inversely, we are saying because a friend, you have a friend of a friend, you are related to that friend. How do you represent that connection? Facebook uses like a graph network to do that, right? So how do we know? Okay, yeah, I need to pull the friends of my friends. How do I do that successfully? And so these are like the things we'll be looking at for in this particular class, and then we look talk. So it promises to be an interesting course. We'll have a lot of exciting solutions. We'll have a lot of exciting challenges, which I look forward to myself, and I hope you are as excited as I am about the whole course. So yeah. So thank you all for see you in the next class. Thank you.